Hello everyone. I'd like to welcome you to our virtual event today, which is focused on transforming application delivery with containers. My name is Tim Yaton. I'm Senior Vice President here at Red Hat, responsible for our infrastructure business group. Red Hat's been very focused on containers sort of visibly in the market over the last year or so, but in fact has been active in the technology for many, many years. Our focus has been on an integrated application delivery platform that spans from the actual creation of an application container all the way through its deployment and management. All of these built on our open standards and open source technologies. So today we're going to talk about how containers can help application architectures in a number of dimensions. Number one, how to deliver applications much faster, providing greater deployment flexibility, and optimize your efficiency while lowering your deployment costs for these technologies. And so we'll do that over the course of our event today. In addition to myself, I'll be providing a bit of context around Red Hat's overall vision and strategy, and particularly how it relates to containers. You'll also hear from Dave Bartoletti, Principal Analyst at Forrester. You'll hear from one of our customers, and you'll also hear from Lars Herman, who's our Senior Director of Product Management for our container strategy. After that, we'll be breaking into 3 tracks, focused respectively on architecting container-based apps, how to do the development of them, and then managing and deploying as well. So let's put a little context around what's happening here. So certainly cloud represents the next major shift in IT architecture. It started as being focused primarily on modernizing cloud kinds of infrastructure, in large part fueled by open source and open source related technologies. And what's been behind that is a desire to drive for business agility first and foremost. What you've seen happening over the last several years is business organizations trying to find ways to deliver solutions to their customers much more rapidly. So how does that organization achieve business agility? Well, first, it's how to improve the developers' productivity, their ability to build solutions for the line of business much faster, and then ensure that the whole environment is efficient and delivers efficiency at scale. So those are the things that have been fueling the cloud trend, and the application model in many ways is catching up to those attributes. The other thing that's a really interesting dynamic in the cloud part of the market and in software in general is the nature of innovation as it's happening today. If you look at most of today's software innovation, be it in storage and big data, in cloud, in a number of other areas, it's all driven from the community-based open source development model. I mean, you see a number of examples here. There's over 1 million open source projects in the world today. And what we do and others like us is we take those innovative community-driven open source projects where innovation is the driver and have mechanisms to turn those into mission-critical consumables by customer. The trend is irreversible. Most innovation is already happening in open source at pretty much all levels of the software stack, and that's important because the vendors that you work with need to be active participants in these upstream communities of development and actually participating directly in the innovation, and also have the skills to take those projects and then turn those into mission-critical customer consumables, as we've been doing for well over a decade. So moving on to containers. Containers really becomes the next wave in application development and deployment, particularly in this hybrid cloud kind of environment. Now, many of you know containers are in fact not new. They've been around for a long time, all the way back to Unix systems, in fact. And we have a decade or more of experience in building the enabling technologies that are already in our platform. Things like SE Linux for security and isolation, C groups, Systemd, and other technologies. What's new with this generation of containers, however, is that the infrastructure is being built to ensure you can build multi-container microservice-based applications with highly flexible orchestration and management across these containers, regardless of what hosts and platforms they sit on. So huge benefits coming with this container model, particularly in a hybrid cloud kind of context. But there are some key considerations to bear in mind. In the end, containers are an operating system in a Linux-based technology, so considerations around how do I ensure that if I build a container-based application, it's a mission-critical supportable platform, and it's running on a host that matches that container, and that everything that I'm consuming is secure. I know its provenance, its origins, and that I've got an ecosystem that I can leverage that helps me build upon this and achieve the kinds of agility goals I'm searching for. So in our case, our whole strategy is really based on serving this a hybrid, multimodal, cloud-based IT environment. And in our vernacular, it's more than just cloud on the public and private side. It's all things that live in the environment, from your traditional workloads on bare metal servers, on classic virtualization infrastructure, all the way out to and including cloud-native workloads that run on private, hybrid, or even public clouds. Now, containers becomes a very powerful common application model for building or modernizing and driving new workloads across this open hybrid cloud kind of context. It really bridges workloads, ensuring that you can modernize your existing application environments while introducing at the same time with the same model new cloud native applications. You can build containers that span your private and public cloud infrastructure very seamlessly, so it's easy to burst workloads and that sort of thing. And also the container model lets you bridge across your development and deployment environments, really delivering on true DevOps. Now, before I leave this slide, just a couple other points I'd like to make. So we've been very focused on supporting all the mission-critical platforms with Red Hat Enterprise Linux and supporting all these elements across. So our bare metal RHEL servers all the way out through and including our OpenShift PaaS platform in its version 3 form all support containers in the absolute same fashion. You can build a container or add it to an existing application and be able to run elements of that app all the way out to and including our public PaaS environment. That's huge, and it's unique in the market in terms of having the ability to build a container once and have it span any of these workloads, public or private, whatever footprint makes sense. And then we have a set of unifying elements that make that hybrid cloud fabric really work. We have a common management framework, we have common storage infrastructure, so you get a single view of your data regardless of its structure, regardless if it's on the public or private side. And also our middleware provides consistency across for applications in any of those footprints. So where are containers going? What's really exciting about containers as a long-term development model is this ability to structure them into flexible, loosely coupled microservices-based applications that can straddle, in fact, multiple hosts. So you're able to share existing services, ensure rapid, agile innovation, and really get real reuse benefits, much more than we've been able to get with previous application developer technologies. But again, there are those important considerations. First and foremost, you need to know what's in my container. What are the operating system elements? What are the application elements? Where did they come from? Because you want to, again, ensure mission-critical supportability, security, and leveraging a certified ecosystem. And Red Hat is focused on all of those elements in building out our container strategy and delivering those for enterprises. And you see that depicted here. So we're really leveraging over a decade of experience building an ecosystem of certified partners, and now we're extending that concept and extending that certification to Linux containers. As part of this, we're launching several elements of our strategy. The first is our Red Hat Connect program for technology partners and ISVs, so they can start to engage and participate on container-based development. We have our Container Development Kit, our CDK, which is a set of capabilities for enabling the building of container-based applications. We're introducing our certification program specific to container and container-based apps. And then lastly, we're introducing a container registry to house those certified containers and certified components. For our partners in particular, this is an exciting time. This is a way to build much more flexible applications. You can modernize existing ones, you can introduce next new, and also introduce a whole range of new business models leveraging this container-based application architecture. So in our vision and our strategy, we're trying to bridge a couple of things that we think containers uniquely does that in a cloud era. The first is providing consistency across both traditional workloads where you can modernize elements of them with containers and build net new cloud native applications using the exact same format, and then have those containers and those applications interoperate. Second is providing a bridge between your private cloud environment and the public side, and having much more flexibility in moving workloads around. And then the last point is the bridge between the development organization and operations to deliver true DevOps kinds of workflows in the context of leveraging containers. So with that, I hope you got a good overview of what Red Hat's focused on. We've got a really exciting day planned for you for the rest of the day. And please take advantage of the other keynotes and of our breakout sessions as we go forward. Thanks very much for joining us.
Hi, I'm Dave Bartoletti, and I'm a principal analyst with Forrester, serving our business technology, infrastructure, and operations clients. And I'm also a member of our cloud computing playbook team. I spend most of my time talking to Forrester clients about their cloud adoption plans and strategies. And as 2015 unfolds, it's definitely an exciting time to be covering cloud. Adoption of all types of cloud services, private clouds and public clouds, infrastructure services, and platform services, are entering what we call the hypergrowth phase. Spending is way up, and use cases are expanding. And software is really the heart of cloud computing. Every company, from auto manufacturers to insurance companies to contractors, to some degree is becoming a software company. Software is how you win, serve, and retain customers better than your competitors. That might be a better mobile banking application, a better media streaming website, or a better customer service portal. And cloud computing is the competitive tool more and more of my clients are using to build and deliver modern software faster. So what does modern software look like? Well, today's mobile and web applications are increasingly composed of multiple components that are built in one place, deployed to another, and might migrate to a third place for scalability. Developers are building these composite multi-channel applications using a wide range of tools and cloud services, and our technology infrastructures need to be hybrid to support that. These new applications will often connect with cloud social media and search services. They will store data in new cloud databases and ERP and billing systems. They will also connect back to inventory and sales systems in the enterprise data center. And they'll collect data from mobile phones and new retail systems and feed that data to analytics engines running in the cloud. So companies have a development challenge. They want to retain the application lifecycle tools that work for traditional systems, monolithic applications that don't and shouldn't change that frequently. And at the same time, they want to leverage modern tools for their more composite apps, built from microservices that must change much more frequently. So most companies will have two application lifecycles, a more traditional one for existing run-the-business type of application, and a second modern one for those grow the business or reach new markets faster applications. New composable apps are driving agile development processes, continuous integration and continuous delivery, and DevOps. All of these terms are strategies to speed up application delivery, and they're focused on two primary objectives: splitting releases into smaller components and iterating changes to those components faster. From understanding requirements through the build, test, release, and run steps, modern applications also require development teams and IT operations teams to work better together. That means getting ops involved earlier in the build phase and keeping developers involved in configuration and deployment decisions. And that's the real promise of DevOps. We don't have time for developers to work alone, then throw code over the wall to ops and ask them to figure out how to run it. So what's really exciting to me is that DevOps is not just for the hyperscale public cloud platforms. Any company can take advantage of the DevOps tools and technologies that these hyperscale web platforms use. Most of them are open source. That means they're easy to try and come with an active community to support them. And if you've been paying attention for the last year, you already know about one of these technologies, Linux containers. Containers are a form of virtualization that lets developers and operations teams wrap up applications in small containers, typically smaller than a full virtual machine, and deploy them on a wide range of operating system and hardware platforms, and increasingly to many leading cloud platforms. Containers offer a lot of promise. The technology itself is not new. What's new is the scale at which they're already being used by some big names in cloud computing, and the work that's being done in the open source community to help more people use them safely and manage them a lot more easily. So to look more closely at how containers can help modern software delivery, Red Hat commissioned a Forrester consulting project aimed at understanding how people are using containers today and how they plan to use them in the next couple of years. What benefits are they seeing? And what they need from the vendor community to make better use of containers. So now I'll share some of our early findings, and the full study will be available very soon. We reached out to almost 200 IT operations professionals, developers, and architects around the world who are already using containers or plan to use them within the next year. First off, we found that interest in containers is very high and adoption is growing quickly. And it's not just for a few special use cases. Companies told us they're using containers to support a wide range of workloads. The users we spoke to are accelerating delivery of big data applications and other cloud-native apps. In fact, over 70% use containers for these applications today or plan to very soon. Solid majorities also use containers not only to support client-facing customer engagement applications, but also to power their more traditional systems of record, like ERP and transaction systems. And as we expected, containers are helping plenty of companies get web and e-commerce applications to market faster. So why are these companies so interested in containers for so many different application workloads? Well, for a lot of reasons. The users we spoke to told us that many benefits of containers were important to them across the board, and these benefits are being achieved by both developers and operations teams. For one thing, our survey respondents told us that containers give them better isolation of applications from one another, which improves security and lets them increase server consolidation ratios safely. And as a result, it lets them increase IT operational efficiency. They also called out portability. They can move containers to different platforms at different stages of the application lifecycle without having to do major reconfiguration at every stage. That lets them accelerate the pace of overall software delivery and gives them more flexibility and choice about where they can deploy application components. In fact, we were pleasantly surprised that companies were seeing the value of containers beyond faster software delivery already. IT operations teams are also already seeing the efficiency and cost impacts on existing infrastructure. So what might have started as a cost-saving measure is now being driven by real business requirements. And that's indeed what one respondent told us directly. We heard over and over again that containers are about both speed and efficiency, about higher quality software and fewer configuration errors. They provide benefits that span both development and operations teams already. But for containers to become part of an enterprise software delivery strategy, you need more than just easy provisioning. They need to have all the enterprise-grade features we expect of any virtualization solution, or in fact, any technology at the heart of your company's most important asset, your software. What challenges have container users experienced so far? Well, first off, security. Without a set of best practices and security management tools to control who can do what or who can change which configuration settings, containers alone just don't have the advanced controls enterprise users need. Users also have concerns about inconsistent performance across their container deployments. So they need better visibility, and that means better management tools. They also told us they need to integrate containers into their existing development tools and processes. And they see a lack of advanced management tools to help with the entire container lifecycle. Rounding out the top 5 list of concerns was a lack of certification or digital signing for containers. So basically, what this comes down to is trust. With such a large community developing containers and sharing them with one another, you need to ask yourself, who created this container? For what purpose? Is it certified to run on my operating system version with the application I'm using? I'd like to point out that we also found that companies who were already using container management tools were much more confident overall. they were less concerned about these challenges slowing them down. Companies who paired containers with advanced management and clustering tools considered themselves further along the path to DevOps and agile software delivery. So taken together, this data tells us that companies are very eager to adopt containers and to adopt them for a wide range of applications. But they don't want container use to become the Wild West. So as you consider using containers for either existing or new applications, we have some recommendations for you. First, talk to your trusted vendors and vendors that are adding containers to existing platforms and ask them how they can help you use containers safely. Look for vendors who are thinking about security today. You want to establish a circle of trust for what you run inside containers, so you can be confident you know where a container originated, why it was built, who built it, and what you can safely use it for. And don't wait until you've already got a bunch of development teams clamoring to use containers before you think about how you'll manage them, how you'll deploy them at scale, how you'll schedule deployments. There are management and orchestration solutions for containers out there today. You don't have to reinvent them yourself. Again, talk to your trusted vendors. And finally, we think containers are worth the hype. The core technology is sound, and the vendor community is quickly adding management and security features to help you use it safely. Containers should be on your radar. They can be a key element in your path to DevOps and can help you deliver software faster and drive up efficiency at the same time. Thank you.
This is Mark Coggin from Red Hat. I'm the Senior Director of Platforms Marketing. So I'm with Jacob Yunt, who's an enterprise architect at UPMC, which is a world-renowned healthcare system provider and payer, and has more than 3,500 physicians and 500 offices in their network, and really using technology to really improve the services that they're delivering to their customers and insurees. So Jacob, let's begin and give the audience a little bit of background on yourself. What are you responsible for at UPMC?
As an enterprise architect, I'm responsible for the areas of Unix, Linux, and all of our high-performance computing systems.
So we understand that you're working with containers at UPMC, and I'd like to understand, why did you choose to work with containers and use them, and what are the problems that you're looking to address with these solutions?
So we had two major sources of demand for containers. One was from the developers. All the developers were running Docker on their workstations or their laptops, and they became pretty familiar with the product, and they wanted a more formal, supported offering of a container solution. And the other side was from our infrastructure teams. My background is in infrastructure, so I can sympathize with them that they were looking for a faster way to deploy the code that had been provided from our developers and sort of avoid a lot of the context switching between the operations team and the development teams of, hey, install this, go make this change, no, do this. So it seemed like a good fit to have the developer say, this is what it's going to look and feel like, go slot this into the environment.
Terrific. So let's get more specific. Tell us a little bit about what products, tools that you're actually using to do this, and why did you choose those particular tools?
Right now we're testing the high-touch beta for RHEL Atomic. It was a good fit for us because we're already a big RHEL shop. We love a lot of the Red Hat products. We're already working with RHEL 7, so using high-touch beta, or the Atomic high-touch beta was kind of a no-brainer. We noticed that there's some stuff that it doesn't have. I know it has Kubernetes and some of the orchestration bits, but we're planning to work with the OpenShift 3.0 high-touch beta because we're really looking for some of the more advanced features in terms of chargeback, showback, monitoring, management, more advanced orchestration. So I think that we're going to start working with the 3.0 high-touch beta in the next couple months.
Great. Let me then kind of shift over to OpenShift v3. And why are you looking at OpenShift version 3? Elaborate a little bit more, please.
So I'm really looking for a solution with containers that mirrors or resembles what we currently have with VMware. So we're a very large VMware shop, and we have a pretty robust infrastructure, vCenter, plus a bunch of ESXi hosts. I would love to have something similar to that with OpenShift. So I want to have a bunch of Atomic hosts, and I want to be able to manage it with OpenShift and have all that feature and functionality that we have with the VMware products, but with containers as opposed to, host-based virtualization. So I think that in terms of what I've seen from the product roadmap, OpenShift 3.0 is really going to have all of those, that feature and functionality.
Great. We're happy to hear that you're seeing the value in what's coming down the road. So let's talk a little bit about challenges and really focus on, again, some of the learnings you've had that can be shared with the virtual event audience. What are some of those challenges you've seen relative to implementing containers within UPMC?
So some of it's just been code maturity. Some of it's upstream, some of it's Red Hat's, prepackaged Docker RPMs. So I know that Docker is totally a moving target. I understand that. I understand that they're rapidly developing. But some of the challenges that we've had revolve around just bugs with Docker and with Atomic. I know that I'm very happy that Red Hat's trying to stay current with upstream. That's great. I'm very happy with that. I would like to see a little bit better QA in terms of when Red Hat backports fixes, or when they try to stay as close with upstream as possible but still delivering a stable product. And I understand that can be a catch-22, that you can't have it both ways. You can't have bleeding edge and have it be 100% stable. But I'm hoping that some of these things get ironed out as we have a couple later releases of Atomic and OpenShift 3.0 gets here.
Great. Yeah, it's good to hear that you're being patient but understand the roadmap and the go-forward plan. So how do you address some of these challenges that you've talked about?
Some of it's just been emails to our developers saying, hey, that's a known defect, that'll get fixed in blah. Others have been, hey, we found something new, we'll let Red Hat know and we'll try to work with them. Some things we try to work around. I don't know if I have a good answer per se of, we've always done X, Y, and Z and that always fixes it because of A, B, and C. But we just try to, deal with it as we go.
Yeah, and let's take the challenges and kind of bring them a little bit to a higher level. Within the organization, are there challenges in either skills or support or other aspects of this within UPMC that you're seeing challenges beyond kind of above the technology level? I mean, this can be viewed on one hand as a sort of seamless change from doing what you do with Red Hat Enterprise Linux, and you talked about how you've been using Red Hat Enterprise Linux 7 for a while now. Is this a seamless change from that, or is this a huge change to the way you guys do things at UPMC?
I would say medium change, and I might answer it in two parts. One, the developer side, and the second part being the infrastructure side. From the developer side, medium change in that they need to sort of, or we're working with them to sort of change how they do their application development. So if they had previously used something like Chef or Puppet to do what we would call, I guess, OS orchestration, maybe, they need to think of, hey, that this will be built into a Docker file or a Docker image. You don't have the full flexibility of a full OS, sort of. And then they need to take that into consideration when rolling it into their continuous integration processes. I think that's not too difficult because, like I said, there's a lot of developer demand for this, a lot of groundswell, so the developers are already becoming acclimated to that. In terms of infrastructure, it's still new to us, so we are, we're sort of working through some support kinks. I think we'll have pretty much everything ironed out, but our goal is to really have it just be a 100% fully supported solution like we would treat any other RHEL installation. And I think we'll get there because we have a pretty good staff and people are really interested in this product. Really interesting.
And I hear in your story here kind of a buzzword that we marketers use often, but I hear DevOps. Do you at UPMC talk about it this way? Do you realize that you are really bringing the developer and infrastructure teams together here so closely through a DevOps methodology?
Yeah, I guess we don't formally say that we do DevOps. I get that that's kind of buzzwordy. We sort of have the traditional roles of, hey, these are developers, hey, these are infrastructure, and then maybe a middle tier that does quote-unquote application support. And I think that we are sort of blending some of these roles as we have different teams work more closely together to say, hey, I'm going to give you this thing that looks kind of like infrastructure. You need to go slot it into your environment. And then when we have infrastructure people saying, hey, you know, you need to make these changes to your code to make this work better. So I think that these roles are sort of, these lines are sort of blurring as we roll this out.
Yeah, I hear that, and I think that's a great thing, actually. And that's certainly one of the benefits we see to this approach, making responsibilities clear and really bringing the teams together to collaborate. So the last question I wanted to touch on, Jacob, is really as we close this portion of the virtual event, to ask you to give some advice to the attendees here. You know, what advice would you give them if they're thinking about delivering application containers into their organization?
That's a good question. So it seems kind of like a duh or an obvious one, but make sure that you have buy-in from your users. When we initially tried to roll out some very early proof of concept environments for Docker, I don't think we had a good understanding of what our end users needed to do or what they wanted to do. So make sure you understand, what your developers are trying to accomplish before you start building anything. Again, that's probably like a duh for most people on the line, but it's something to always take into consideration. And for us, it really helps to have sufficient resources to work on this project. If you can get 1 or 2 people to be SMEs on this, that's really helpful. We've had a handful of other projects that we don't have the manpower to work on them, and they sort of die on the vine. So I think because people are so excited about this, we're able to have enough resources to assign to these projects. But make sure you understand the needs of your users, and make sure you've got people to actually work on it. And people who are interested in working on it too helps as well.
Thanks, Jacob, and I think that's very helpful advice for everyone. Thank you for joining us here today for a little while to really share your insights with the audience. I think it's been terrific. We're happy and excited to hear the progress you're making with the changes and the work you're doing. We look forward to hearing the success more publicly as it rolled out, and you become really a poster child for how this container technology can really help you transform application delivery, but hopefully others can learn from your experiences. So thanks so much, Jacob, for your time.
Yeah, thanks for having me.
Hello, everybody. My name is Lars Hermann, and I'm responsible for the strategy of our platform products. Over the next few minutes, I'm going to walk you through how containers transform application delivery. Let me start with the high-level problem. The problem that containers are really targeting and where they play is the tension that exists between the business side of the house and development teams who are all about driving innovation and accelerate the delivery of applications to customers and markets. And on the other hand, the operations side of the house, which is driven by availability, by cost, by security and regulatory compliance. And more often than not, these two groups perceive each other to get into the way of each other. Containerization provides a very powerful set of tools that enables these two groups to work with each other in a new way. Because of the separation of ownership that becomes possible with the development team owning what goes into the containers, the application, all the dependencies, and the operations team owning the infrastructure on which these applications get deployed. Putting these two things together enables a new way of working together, which increases agility, developer productivity, and also makes it easier for the enterprise to adopt different environments, such as public clouds, in a consistent way to how they operate in the data center today. There's a lot of excitement about containers, and it has accelerated enormously over the last 2 years. And along with the excitement, there were also misconceptions tossed around. Tim already introduced how containers are not really new. They have been around for a long time. A lot of confusion exists around containers being compared to virtualization or being seen as an alternative to virtualization, which in a way might be possible, but is really not the point. We believe containers complement virtualization. They both operate in similar ways, but they function based on different technologies, and they achieve different outcomes. Because containers are not the same as virtualization, a container is not as portable as customers think of virtual machines today, and it's maybe also not secure as customers think of virtual machines today. So let's dive into the security challenge. A container in itself is only as secure as the degree of isolation that exists from other containers and the underlying host operating system. In Red Hat Enterprise Linux, we have integrated container support in the kernel with SE Linux, our technology providing mandatory access control with hard policy enforcement in the kernel. So by doing this, a container is truly confined and contained to just its own runtime environment, cannot interfere with the host or with other containers. The second security challenge around containers is about what is actually inside a container, and how do you know what's in there, and can you trust it? And if there is a security issue coming around, do you have a way to fix that? This is what Red Hat addresses with container certification, which speaks to two value propositions. It starts with all the runtime products, libraries and services that you use to build a container, that end up inside the container. These are the components of the operating system or the middleware stack that is inside the container, and by building them on Red Hat products, you get the enterprise class security, maintenance and support for the application inside the container. Similarly, we are offering container certification to our partners, and this is why we are here today, as a service, so customers can consume certified containers that they can trust where they come from, what is in there, is it a supported solution, and is there a path to solve security issues going forward. In order to enable certification, we provide all the tools necessary for ISV partners to participate in the container value chain and deliver the benefits to their customers. As Tim already explained, it starts with a new platform where partners can learn about containers and how to use them and learn about the best practices. Through Red Hat Connect, they get access to all the tools that are necessary to build their containers, to develop the application, to package them, to test them, to optimize them, so the customer gets an optimal experience. Then they can submit these containers to the certification service in Red Hat's portal, where Red Hat runs tests and then lists the container in a catalog, where then the ISV can take it and make the container available to their customers using a registry that he runs for his customers. So Red Hat enables this journey for its partners as an end-to-end solution to make it easier and enable widespread adoption. Now let's look into widespread adoption for the customers. What do we need to enable customers to take advantage of containerization across all their applications, across their infrastructure? A lot of it comes down to standards. We have seen the technology stack evolving on top of the capabilities in Linux, which we have been driving for many, many years, adding a unified and standardized format and front end that Docker brought to the table 2 years ago. But that is not the end of it. Applications in a container paradigm are inherently consisting of multiple services and containers. Orchestration is required to connect all these microservices and enable the application to function, but also to scale up and down depending on its performance need. So Red Hat drives Kubernetes as the orchestration technology, backed by Google, because it is very mature in design and is highly flexible in implementation, which is a critical requirement for us, supporting our products and customer applications in very different environments. Last but not least, the Docker technology also comes with a registry protocol that standardizes the consumption and the publishing of containers into a federated architecture, where you can consume containers from lots of different repositories and places across the internet. You can have your own, you can rely on third parties, and having a standard across all these layers provides a strong foundation for building out the solutions for the next generation enterprise IT. One key requirement that we hear all the time from partners and customers is portability. There is a belief that an application, just because it is in a container, is portable. And for the most part, that's not true, because the application still depends on its libraries, but also the underlying Linux host OS all the way down to the hardware. Red Hat enables portability in multiple dimensions. We enable portability across bare metal, virtualization, private and public cloud, as Tim has explained. We also enable portability across our platform portfolio, from Red Hat Enterprise Linux to Red Hat Enterprise Linux Atomic Host to OpenShift, which can run on top of private or public cloud infrastructure. So by driving this portability into the technology stack, we enable applications to be mobile across different platforms running in different environments, and we enable a lot of choice for our customers to build out these infrastructures and optimize for every footprint or application. what the enterprise requires to put all this into their environment and run it consistent with their policies and their operational procedures, we need more than just a platform. We need what Red Hat calls the atomic application architecture, which is the end-to-end solution. It starts with a cloud-ready foundation across the deployment targets, which is required to enable the portability, as I just explained. It then extends with the container-based application fabric that drives the orchestration across the resources and the deployment targets underneath, but in a way that works for many applications sharing multi-tenant infrastructure. It then adds the complete end-to-end lifecycle from development to production and the experience for development of application, for certification, and by distribution and deployment. This is what we're driving into our products and our partner programs, as you see today with our announcements. And last but not least, in order to operate applications and infrastructure at scale, customers need management tools, strong management tools. Red Hat drives its hybrid cloud vision into its management products, and we're also integrating the container paradigm into these products, so there is a single pane of glass that shows customers and enables them to manage their workloads across the different platforms, across the different footprints, meeting business needs. Putting it all together, Red Hat is committed to the benefits of containerization. We are driving containerization into all our products, services, and programs. And by doing so, we enable the three main benefits. We solve the three key problems that customers need to adopt containerization. It starts with containers you can trust. So you know what you're running, and you know where it came from, and you know how to update it. We enable proven container portability, so you have the deployment flexibility that you need to make choices when you want to make them and how you want to make them. And we integrate the technologies into an integrated application delivery platform that provides a rich user experience and at the same time has all the enterprise attributes around reliability, security, and manageability. With this, I'm at the end of this session, and we are shifting now to a question and answer session. So if you have any question, please type it at the chat box in your window, and we'll try to get to as many questions as we can. Thanks.
Good afternoon, good morning, wherever you're logged in from, and this is Mark Coggin, Senior Director of Platforms Marketing here at Red Hat, and I want to thank you all for attending the virtual event and for listening to our esteemed speakers so far this morning. I'd like to just reintroduce who we have on the phone for the live Q&A today. We have Tim Yaton, who is the Senior Vice President of the Infrastructure Business Group here at Red Hat. We have Dave Bartoletti, who you heard from, who is the Principal Analyst at Forrester Research. And we have Lars Hermann, who is the GM and Senior Director for the Containers business here at Red Hat. So just to get one item out of the way, I think there were a few questions that came into the window about a raffle that we're running. So if you are logged into this virtual event, you will be entered into a lottery where two passes to Red Hat Summit later in June here in Boston will be drawn, and we're excited to see you there. But we're going to go through questions that have been coming in over the chat window over the last 45 minutes or so, and address as many as we can, and any that don't get addressed we'll follow up directly with you offline through your email. So let me begin by asking Dave Bartoletti a question. Dave, you mentioned in your talk about modern composite applications versus traditional ones. And so which of these are organizations using containers to deliver today?
Hey, thanks. Sure. Well, when we did the survey, we expected to see containers really being used only for these modern composite microservices apps. But what we found when we talked to enterprises that are currently using containers and the ones that we're planning to in the next 12 months or so, we found plenty of companies already using them to drive up efficiency for their more traditional monolithic apps. So I think today what we're looking at is containers really lend themselves most easily to accelerating development and especially scale out of smaller components that people build in the cloud to run in the cloud. But as security gets better, as management tools mature, I think we'll see the number of enterprises looking to containerize even their core business apps increase. It reminds me of what we saw with server virtualization. I know you were there as well. What started in test dev or for one class of rapidly changing apps or workloads eventually spread to be useful for almost all types of apps. But that happened once companies felt comfortable that they really had a handle on enterprise security and management. Does that make sense?
Yeah, it makes perfect sense. Thanks, Dave. So Tim, I'll throw a question over to you. Most companies are going to bridge traditional and new age technologies, and how will they contend with this?
Well, Mark, I think Dave hit on some core essential points. What we're seeing is companies are going to be inherently hybrid. They're going to continue to invest in and support and maintain traditional workloads, and as Dave just said, seek to modernize those, make them more efficient, maybe containerize them, maybe scale out certain tiers of those applications. So I think, and they're going to build their net new cloud native, more agile workloads. So I think that's the reality, and that some of those latter ones are going to live outside the firewall, some in. So companies are going to build these open hybrid cloud infrastructures. I think the way that they'll contend with that is to sort of let nature take its course where the applications are concerned. If it's a stateful scale-up app, so be it. Those aren't going away for sure. And then build net new cloud native, but have a common set of underpinnings that build the fabric of the underlying. And in our case, that's things like having a common storage substrate that can access data for whatever the workload is, whatever the footprint it happens to be deployed on. Management, clearly an important one. We have a management strategy in our satellite and CloudForms product offerings that provide the ability to bridge across these sort of traditional new environments with a common pane of glass for provisioning, management, monitoring, and the like, regardless of the workload type, regardless, again, of where it gets deployed. And then the whole application enablement model itself, from middleware up to and including containers, those become unifying elements, in both, classic traditional scale-up apps and these net new cloud native. So it's about having enough commonality in the management fabric, the storage fabric, and the like to really make that easy to live with and evolve.
Yeah, and so almost a new age of application integration technology.
Right.
Yeah, great. So Dave, let me also now direct a question that came in to you. It says, I've read a lot about comparisons of containers to virtualization, some going as far as saying containers will replace virtual machines. Will this happen?
Not anytime soon. I don't think there's a current efficiency crisis with most virtualized applications. That's not, I think in the eyes of most enterprises, what's driving the move to containers is a significant problem with current virtualization approaches. We've spent the better part of the last decade driving up server efficiency using virtual machines. And for a long time, there's going to be apps that run fine in a virtual machine and where companies have built processes and infrastructure to harden and optimize those. And there's going to have to be a real compelling reason to move them. I think it's a strong parallel with cloud migrations in general. There's going to be a lot of workloads that are going to stay on-premise because they're optimized to run on-premise, and we've spent a lot of time making them as efficient as possible over the last decade. And there needs to be a compelling both economic and performance reason to move them to the cloud. Same with containers. But I think for new applications, those that are built for hyperscale, which need to be as scalable and, as you've mentioned, as portable as possible, that's key here to deliver on the promise of container portability. Containers are going to offer a smaller package and faster start times. And so most companies are going to have both VMs and containers for a lot of years to come.
Yeah, we would agree with that exactly, David. Lars, I'm going to direct a question to you that is very much related to the topic that we just had Dave talk about. Like virtual machine sprawl, will container sprawl become an issue for the IT organization?
That's a great question. The answer is yes. We get this question from customers a lot, asking for how do I think about container sprawl, and really the whole point of containerization is to enable the flexibility for the development teams to decide which components to put into the container, when to drive a change inflicted by security or inflicted by what the application needs. So it's inevitable that there will be lots and lots of very different containers deployed across the enterprise. So the problem is not about avoiding sprawl, it's about being able to manage sprawl. And this is what we are driving into our product portfolio to make it easy for customers to actually have the inventory of which components and technologies are included in which containers, and at the same time have the tools to drive change as it is necessary. So we believe we can manage that. We have demonstrated this in OpenShift in the last 4 years, running over 2 million applications that are very diverse and very different. So we believe it's a manageable problem. We just have to make that easy for IT to meet all the requirements around security and compliance and not get overwhelmed by the complexity in this new world.
Thanks, Lars. So I'm going to address a question about specifically with managing container infrastructure with CloudForms, one of Red Hat's products, which is our hybrid cloud management solution, and then also meld that with another question that came in about how does Red Hat's management portfolio address containers. So Tim, if you could talk about sort of the broad topic, but also CloudForms a little bit.
Yeah, so I think in the broadest context here, we have always envisioned, CloudForms and Satellite as this common management fabric, as I alluded to a minute ago, and that includes extending to containers as first-class citizens from the standpoint of the elements that can be managed. So, we're going to be able to provision, monitor, manage containers as they live in the environment. Again, whether they're net new for cloud-native apps or if they're elements of a traditional app that's been modernized with them. So CloudForms will provide inherently the ability to manage containers as it can manage VMs and workloads like that. The other thing that's important, I think, about CloudForms in particular, particularly in regards to how we see customers building these hybrid fabrics, is it's inherently heterogeneous. So not only can it manage container workloads across those environments, it can manage classic VMs, not just on Red Hat's virtualization infrastructure, but also Microsoft's and VMware's. Likewise, it can push and manage workloads out to public clouds, our own through OpenShift Online, those of our cloud partners, as well as Amazon and Google as well. So that's all sort of built in, and it's been part of the vision all along, and it's really extended now to make containers a first-class citizen in that environment.
Great. That's a very important aspect of the whole story. No question about that. Lars, I'm going to address a specific question that came in, but also maybe up-level it a little bit. So if you could sort of do both. The specific question was, can one build RHEL 5-based containers for applications? But I think the broader question is really how one builds previously supported or previously certified applications on, say, RHEL 6 in a newer age container environment for targeted RHEL 7 hosts. So that's the kind of the question in a nutshell.
Okay, so let me answer it in two parts. The first part really is, as we have established in the presentations, containers are not automatically portable across all kinds of different Linux environments or runtime environments. So we are very comfortable to commit and support a RHEL 6-based environment on top of a RHEL 7-based container host, because we can keep the customer experience in terms of security, performance, scalability supportable and meeting enterprise requirements. That said, today RHEL 5-based applications are not supported by Red Hat in a container environment, and the main reason really being that the user space that RHEL 5 introduced in 2007, which we maintain actively, but mostly in the form of really fixes. It hasn't really been keeping up with all the innovation that provides better support for multi-core or generally SMP processing, NUMA, all capabilities we have in the RHEL 7 infrastructure, which applications in a RHEL 5 environment could not easily take advantage of. So we have delayed that question to test the market on what is really the demand and the need for that. So it wasn't as much a no-brainer as RHEL 6, which we knew is going to be super important to enable customers to take advantage with the existing applications of this new application delivery paradigm. So we might get there in the future, but it becomes a question of demand and what is the technical experience that we can deliver and stand behind as an enterprise vendor.
Thanks, Lars. That helps a lot and answers the question for sure. Dave, kind of back over to you. And the question is, from someone who's saying, we're seeing instances of shadow IT around containers. Are your clients seeing this as well?
That's a good question. So, yes, there's plenty of shadow IT around any cloud technology. Buying of infrastructure on a public cloud environment, downloading and using chef recipes, excuse me, and especially around containers. We're seeing a lot of organizations find out that these new technologies are being used after someone has downloaded them and started showing some value. So that's the positive side of shadow IT. I think the reason that shadow IT is going to be with us for a long time is that core cloud technologies are often open source based. So that means they're really easy to download and they're really easy to try out. And especially there's a very vocal community of others encouraging developers to try them. So rather than trying to stop shadow IT, right, I think the best way to address it is to start breaking down any walls you find separating your development and operations teams. And that means getting IT involved earlier in app design, and it means getting developers involved later, meaning in configuration and deployment decisions. The successful DevOps teams that we're finding are really cross-functional teams built around products instead of around specific skill sets. Once you start building teams around products, it's much harder for shadow IT to get out of control, for those two groups to not know what the others are doing, or even more importantly, for management not to know what's going on. You can bolt on governance later, or you can implement good governance and oversight from the start by encouraging people to try new things and then offering support to help them make them enterprise ready, or you can, bolt it on at the end. And obviously, we encourage you bolting it on up front.
Great. Thanks, Dave. Lars, a specific question about our recent announcement a few weeks ago. Will the Container Development Kit, CDK, be made available for end users like us to leverage to develop containers within our organizations?
Yes, the answer is yes, absolutely, we'll be getting there. The focus for the CDK, as we released it 2 weeks ago, was really to fit into the ISV journey for containerizing their workloads and get them to deliver them to customers as a certified solution. So the focus for the CDK today is really about enabling an easy on-ramp into being able to develop, test, and submit containers. So the focus for us has been on integrating a role-based environment in which you can easily consume all the runtime choices from Red Hat for inclusion in a container, but then also the integration with certification. So the version 1 was very focused on ISVs. Now that said, our plan is to bring a similarly compelling value proposition to our customers over the next couple months, and then specifically focus on the ability of customers to not only build a container, but also for the IT organization to be in control over what is available to developers to choose for inclusion in these containers. Maybe not as a hard policy, but at least as a way to track. So there is an end-to-end audit trail for what ends up in these containers. And at the same time, of course, we also have to improve and enhance the developer experience to the extent that it fits into their tool chain that they have today, as well as their environments. So there is going to be a continuum in enabling enterprise IT to enable containerization with the simple tools like the CDK, which I would describe as the basic tool set, all the way up to the more integrated platforms, as we will see in OpenShift v3, which of course integrates a complete developer experience with the platform and the automation around the lifecycle. So we will provide a range of choices for enterprise to pick from.
So Lars, while you're on that same thread, a question about how are companies addressing security concerns around containers? Maybe just quickly shed a few thoughts on that too.
Absolutely. So security is one of the top concerns, as we heard also from Dave and the data we have seen. And it really, in order to manage the security of a containerized environment, customers should think of at least 3 dimensions of this. There is a lot of uncertainty and I would say worry also from customers about the degree of isolation with containers. We have really the integration with SE Linux enables a very secure out-of-the-box configuration that customers can rely on. And at the same time, SE/Linux enables, by applying custom policies to harden and tighten the security up from an isolation point of view even more, that becomes the normal trade-off with every security technology between maximum security on one hand versus flexibility on the other end. So that's a trade-off where customers can decide where they want to live, and SE/Linux is going to be the tool. The second component is really the security of the runtime that lives inside the container, which is mostly a maintenance question. So that, as I said, breaks down to the ability to know what is in there and where it came from, and can I trust these components, or do I know there are any known issues, such as a security vulnerability that is just written all over the press. At the same time, is the practical ability to apply changes to these containers, and this is about automating the update model. Containers by design should be seen as immutable. So you're not really patching the running container, you're replacing it with a patched version. You can patch a version, but that is kind of not a best practice. That sort of puts the container outside of its lifecycle path. So as I said, our vision is to provide the tools from the platform integration all the way to management across a hybrid cloud environment to make that inventory and patching and updating very easy, to then be able to make statements about the security of the environment as a whole.
Great, Lars. Great insights. So we're at the top of the hour, and we're going to have our last question, and I'm going to direct that to you, Dave. So for companies that are using containers, are there expectations being met, and which ones aren't being met?
Sure. Well, I think we got a good snapshot of that in doing the research early this year. What the data tells us is container users are seeing three key benefits today already: higher quality releases, better application scalability, and they're having an easier time rolling out these finer-grained microservice-style apps, so easier deployment. But fewer tell us that they're already seeing application startup times decrease as much as they'd like, or that deployments are overall much simpler, or that they've managed to reduce deployment errors as much as they want. So I think what the last three point to is it's time for container management tools to help make all of these deployments simpler, reduce inconsistency across them, and reduce errors. And I think this is what we'd expect for a technology at this stage in its maturity level.
Thank you, Dave. So I'd like to, first of all, thank all of the attendees and viewers who joined us today for the last hour to hear point of view and industry experts like Dave from Forrester, and really understand where Red Hat is going in this area. I'd like to thank our panelists for the insights they shared and the time they took to address the questions that have been coming in over the chat window. And finally, I'd like to certainly direct you to follow up with Red Hat as you see fit, whether that's through our website, redhat.com, or connecting through us through the virtual event registration. And then of course, you'll see after this webcast finishes, you'll see on your screen the various breakouts that are now available for you to go in and learn a little bit more about further detail on managing containers, on kind of the underneath the container infrastructure, how to do atomic updating, the certification program. There are 3 tracks geared to various audiences that we'd encourage you to attend. So you can click into the panel you'll see when this call ends, and then go into an on-demand stream for 3 different tracks, and they're all available, so you can actually click into 5 different topic areas at your leisure, either now or down the road if you have extra time. So with that, again, I'd like to thank you for spending an hour with Red Hat, and look forward to engaging with you in the market and hearing how you take advantage of container technology to transform application delivery. Thank you very much.